Okay, so after collecting data, we can explore the data using tables and graphs, and for that, we can use frequency distribution, uh, which can help us to organize and summarize the data. So, in this section, we're going to talk about what is frequency distribution and then how it can be helpful to understand the distribution of data set. For that, we use the frequency distribution. What does that mean? It shows how data are partitioned among several category. So we might have data of category, different category, and then what is the frequency of each category can be seen by using frequency distribution. There are some of the definition we have to understand: lower class limits, upper class limits, class boundaries, class midpoints, and class widths. Sometimes we can categorize the data using different classes. It's like, let's say you have the data from, for example, let's say you have the data from 0 to 10, 10 to 20, 20 to 30, and 30 to 40, for example. So let's say we divide data into different categories, 0 to 10. Let's say this is the frequency, which is 5, meaning from 0 to 10, there are 5 datas. That's called frequency. And we can, just write down the frequency on the y-axis here, and then the data interval on the x-axis here. So let's say from 10 to 20, the number of data are, let's say, let's say, for example, it's just example 7. So that horizontal, the value on the y-axis represents the frequency of that data belongs to this interval from 10 to 20, and we can keep going like that for 20 to 30 and 30 to 40. So I'm going to use this example to explain this definition. Lower class limits. So as you can see that the smallest numbers that can belong to each of the different classes. So as you can see here, the classes are 0 to 10, 10 to 20, 0 to 10, 10 to 20, 20 to 30, 30 to 40. Sometime what we can do is we can just say, okay, I want to take data from 0 to 9 in the first interval, 10 to 19 in the second interval, 20 to 29 in the third interval, 30 to 39 in the fourth interval, something like that. So in that case, you can see that this 0, 10, 20, 30, they are lower class limits. 9, 19, 29, 39, they are upper class limits. The largest numbers that can belong to each of the different classes. Class boundary means the number used to separate the classes, but without the gaps created by the class limits. That's called class boundary. A class midpoint, the values in the middle of the classes. So if you go back here in the classes, the middle of this interval, which is 5, 15, 25, and 35, that's the class midpoints. Class width, it's a difference between two consecutive lower classes, meaning as you can see that the difference between 0 and 10, 10 to 20, as you can see that it's all of them are, the difference is 10. 10 minus 0 is 10, 20 minus 10 is 10, 30 minus 20 is 10. That's called class width. And so to construct a frequency distribution, first of all, we need to select the number of classes. How many classes would you like to use? It could be something between 5 and 20. That would be meaningful. That's up to us. 5 to 20 is meaningful class size. And then from there, calculate the class width. We can use the class width, which is, as you can see here, class width is the difference between two consecutive lower class. In this example, the class width is 10. To find the class width, we can use this formula, which is the maximum value minus minimum value over number of classes we want, and round this result to get a convenient number. It's not always exact number. Whatever number convenience for us to play with the data, that's what we're going to use for the class width. And number 3, choose the value for the first lower class limit by using either the minimum value or convenient value below the minimum. So that's how we can find out the first lower class limit. Using the first lower class limit and the class width, list the other lower class limits. So for example, here the first class limit, lower class limit is 0 and class width is 10. So next class, lower class limit would be 10, next would be 20, and next would be 30. So that's our step 3. Using the first lower class limit and class width, we can find out the rest of the lower class limits. List the lower class limits in a vertical column and then determine and enter the upper class limits. Take each individual data value and put a tally mark in the appropriate class. Add the tally marks to get the frequency. For example, let's say this is one example, which is a commute time in Los Angeles. Using the daily commute time, so this is the daily commute time, this is the data we have, so this is our data, and we want to use the frequency distribution. So if you look at the data, you can see that the lower number, the smallest number is 5, and then largest number is 90, and the number of data, the difference between the, if you go back here in this formula for finding the class width, it's a maximum value minus minimum value over number of classes. So how many classes would you like? So in this example, we are using 7 classes. 7 classes. So 1, 2, 3, 4, 5, 6, 7. And if you divide this 90 minus 5 by 7, that will give you some number. And from here we can find this frequency distribution. So how we are going to do that? So first of all, 90 minus 5 divided by 7 is 12.1, which is approximately 15. By taking 15, it would be easier for us to do the calculation. That's why we took 15. Now, the first lower number is 0. Second lower limit is 15. And then third one is 30, 45, 60, 75, and 90. That's how we find the lower limit. And then because of the class width, we can see the upper limit is 14, 29, 44, 59, 74, 89, 104. Now we're going to look at this data and we're going to find out how many datas are there from 0 to 14. We count them and there are 6 datas. So from 15 to 29 there are 18, from 30 to 44 there are 14, from 45 to 59 there are 5, and keep going like that. This is called frequency distribution. Okay, so this is the lower limit and then upper limit and then the frequency. So we can also find relative frequency distribution. Relative frequency distribution is a frequency for a class divided by sum of all frequency, and percentage for a class is frequency for a class divided by sum of all frequency times 100%. So relative frequency and percentage frequency for a class can be found by using this formula. Relative frequency distribution or percentage frequency distribution, each class frequency is replaced by a relative frequency or percentage frequency. Okay, so for example, if you look at the very same data here, so the total number of data is total how many numbers are there. So if we go back here and count it, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 times 3 is 51. There is no one data. So altogether there are 50 data, and for the first class interval there are 6. So for finding the relative frequency, it's a 6 divided by 50. If you want to find the percentage, multiply this by 100%. So that gives you the percentage, so which is 12. That's how we can find this 12%. 6 divided by 50 times 100 gives you this. Similarly, this frequency divided by 50 times 100 gives you this relative frequency for the second class, and so on, so on. Combining 2 or more relative frequency distribution in one table makes comparison of data much easier. So for example, let's say this is the commute time in between 0 to 14, 15 to 29. In Newark, there are 8.6% of the data takes in this category, but in boys, which is 30.3%. So we can compare this data, how many percentage takes this much time. Okay. Because of the different size of these two cities, we might expect the commute times to be very different. By comparing the relative frequency, we see that there are major differences. The boys' commute times appears to be lower than the newer commute times. As you can see here, 70 the lowest two classes have 75.8% of all of all okay. See that for boys the lowest two classes have 75.8%. As you can see here, 30 plus 45 is 75.8%. So they take less time, less than 29 minutes. Okay, so in that way we can read the frequency table, and it's very easy to read the frequency table. Oh, okay, now how we can do the critical thinking using the frequency distribution to understand the data. In statistics especially, we try to use the normal distribution. And what is the normal distribution? If the frequencies start low, then increase to 1 or too high frequency, and then again decrease to a low frequency. So start with the low and then go up, and then after some point it goes down, and then again if you get this type of frequency, then that's called normal distribution. So there are two property data should satisfy. The distribution is approximately symmetric. As you can see here, this distribution is approximately symmetric. Both sides, it looks very, very symmetric. Okay, so that's called normal distribution. Okay, now as you can see here, let's take one example here. From 0 to 14 the frequency is 2. Now it's getting higher, higher, higher. This is the maximum one, and after that it's getting lower, lower, lower. So that's why it's a normal distribution. The presence of gaps can show that the data are from two or more different populations, but not the vice versa. For example, here as you can see, this is the frequency distribution for the table. Here is a frequency distribution of the weight in grams of randomly selected pennies. From 2.4 gram to 2.49 gram there are 18, and as you can see here, from 2.6 to 2.69 to 2.79 and 2.89 it's 0, and right after that there are frequency more and more. So that is possible because pennies made before 1983 are 95% copper and 5% zinc, but pennies made after 1983 are 2.5% copper and 97.5% zinc. So because of their two different time frame, this frequency distribution represents, because here you see the gapping, there is no frequency. That means it's coming from two different tables. Okay, so that's about the frequency distribution. I'm going to show you a couple of examples here. For this example, we can also use StatCrunch or Excel to deal with this this value. So first question, refer to the table summarizing service time in seconds. So this is the frequency distribution of diners at a fast food restaurant. How many individuals are included in the summary? So total means you just have to add all the frequency, which is 22 plus 8, 30 plus 14 is 44, and then it's a 50. So total frequency gives you the total number of data. Let's go here to the next question. Is it possible to identify the exact value of all of the original service times? So the service times in between 60 and 119 seconds, there are 8 datas, but we don't know exactly out of those 8 data how many them took 60 seconds or how many them took 70 seconds. We don't know about that information. So the answer should be no. The data value in each class could take on any value between the class limits inclusive. And another answer is no. The frequency distribution tells nothing about the data values that fall below the lowest class limit or above the highest class limit. So the answer is this one, because we don't know exactly the data value in each class could take on any values between the class limits. So that's our answer. Let's take another question. Question number 5. We have given the frequency distribution one more time. Does the frequency distribution appear to have a normal distribution? Keep in mind, to have a normal distribution, the data should satisfy these two property. The frequency start with low, then increase to 1 or 2 high frequency, and then decrease to low frequency. And data should look like symmetric. So here it's start at 3 and then goes down 0. So it's not normal distribution. So answer is no, but which no? You have to read. No, the distribution does not appear to be normal. C is no, the frequency do not decrease from maximum frequency. So the answer is A. Let's go to question number 10. Here we have given data. It as you can see here, 1 2 3 4 5 1 2 3 4 5 6 7 8 9. So there are 45 data set, and we need to create the frequency distribution table here. And according to the information, it says begin with the lower class limit 70, use the class with 40. So what happens is, to get another lower class limit for the second class, it would be just add 40. So 70 plus 40 is 110. Keep adding 40 here. 110 plus 40 is 150. 150 plus 40 is 190. 190 plus 40 is 230. So now upper class limit is just 109. So any data from 70 to 109 belongs to the first class limit. And then similarly, users can fill 149, 189, 229, and then it's 230 plus 40, 270, but it should be 269. Now we have to count how many of data are there from 70 to 109. So as you can see here, if you click the you have to count it. There are two ways to do it. One, you can do it manually. Other one, you can just use StatCrunch here, which is Excel. So to use the StatCrunch, first of all, I sort this data from lower to upper. And this data is not sorted, so we can just use stat, and there is data, and there is a sort, and use variable 1, this one first column, and then just sort it. Okay, where is that? Okay, variable 1. So this is the column we are calculating, and we're going to sort it. Now it's sorted. Look at here. It's started from 76, 78, 79, 83. So when we look at this data, we can now say, okay, how many from 70 to 109? 109. Up to here, there are 10 data. So you can just put 10 here. Okay. And then from 110 to 149, so 110 to 149, 110, keep going. So it start with 11, 149. So here 31. 31 minus 11 is 20. So it start with 11, and there is a 31. So 31 minus 11 is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Sorry, 21. 31 plus 11 is 20, but including 31, so it's total number of data is 21. One more time. 1 2 3 4 5 6 7 8 9 10 12 13 14 15 16 17 18 19 20 21. So from 110 to 49, there are 21 21 data. So now you keep going like that from 150 to 150 to, so what is that, 150 to 189. So so it's start with 32. So we go up to 189. Where is 189? So here 32 to 38. So 6 7 1 2 3 4 5 6 7 7 frequency. From 190 to 229, 190, what is 190? So 221, 1 2 3 229, 4, 4. And finally 232, 269, 1, 2, 3, 3. So altogether it should be 31, 38, 42, 45. It should be 45 data. As you can see here, there are 45 data. So that's right. Okay, so that's how we can find out the frequency distribution. Let's do one last problem from this section. To answer this question, you have to first find the frequency distribution the way we found in last question. Okay, here is no data. Here we have given information. Among fatal plane crashes that occurred during past 55 years, 446 were due to pilot error, 52 were due to other human error, 485 were due to weather, 130 were due to mechanical problems, and 396 were due to sabotage. So total data, you can add them all, this number 446, 52, 485, 130 and 396, add them all, and to find out the relative frequency percentage for each of them, like for pilot error, just divide 446 by the total data and then multiply it by 100. That will give you the percentage. I'm going to use where is that, StatCrunch here, and that will copy my data here. And now I can just find out sum of, if I can use the formula. Okay, I can't use the formula, so I'm just going to use this graphing thing. Let's say I'm going to use pie chart. You don't know about it, but if you use the pie chart, that will give you you don't have to do it. Just let me just use calculator here, calculator. So I just need what is that, to add these numbers. Okay, 446, 52. So I'm going to add this number 446, 52. Where is that? I'm using calculator right now. 446 plus 52 plus 485 plus 130 plus 396. So it's a 1509. So one more time, it's a 446 plus 52 plus 485 plus 130 plus 396. It's a 1509. So for each category, we just have to divide these numbers by 1509. So what is that? This one. So pilot error, which is 446. So divide this 446 by 1509, which is approximately 29 point, round to the one decimal place, which is 0.29555. If you multiply that by 100, that will give you the percentage. If you round it to the one decimal place, which would be 29.6. I'm going to do the same thing. I'm going to divide 52 by 1509, multiply it by 100. That will give me 3.5. Is that, yeah, 3.5. One more time. For next one, I'm going to divide 485 divide by 1509 and multiply it by 100. That will give me 32.1. That's weather, 32.1. And next one, 130 divided by 1509. Keep repeating the same thing and round it to the one decimal place, 8.6. And finally 396. 396 divided by 1509 times 100, which is 26.2. 26.2. Okay, at least one of your answer is incorrect. Okay, what is happening here? Okay, this one, 3.5. So it's a 52. Let me do it again. 52 divided by 1509 and multiply it by 100. Okay, if I round it to the one decimal place, it should be 3.4, not 3.5. I did a mistake there. It should be 3.4. Excellent. Now, based on this frequency distribution table, what is the most serious threat to aviation safety? As you can see here, the most high relative frequency is 32.1% from the weather. So we can say that weather is the most serious threat to aviation safety. Weather monitoring system could be improved. So that's our choice. Okay.